Hey everyone, and welcome to our deep dive today.
Yeah.
We're going to be exploring, all those incredible forces that shape our planet.
Oh, yeah.
Everything from, you know, dramatic earthquakes and volcanoes
Right.
to the slow and steady work of rivers and glaciers.
Yeah.
It's going to be a journey to the center of the Earth and back again. And I've got an expert guide with me to help us navigate all this fascinating terrain.
Well, I'm excited to be here, and it's always exciting to dig into, you know, the powerful forces that shaped our world over millions of years.
Yeah, so when I picture the Earth's interior, I think about that classic image of a solid core surrounded by all those layers of molten rock. But the thing that really struck me doing the research was this idea that this molten material isn't just sitting there.
It's not static.
Yeah, it's constantly moving, almost like a giant underground convection current.
Exactly. It's this constant churning of molten rock, what we call magma. That's the driving force behind a lot of the geological processes we're going to be talking about today. Imagine a pot of water on the stove.
Okay.
As that water at the bottom heats up, it becomes less dense and it rises, while the cooler water at the top sinks.
Right.
That creates a circular flow, and it's a similar process that's happening within the Earth's mantle, the layer beneath the crust. And this movement drives those lithospheric plates, massive slabs that make up the Earth's crust. And it's their interaction that causes earthquakes, volcanoes, and the formation of mountains and ocean basins.
So just to clarify, the lithospheric plates are these huge puzzle pieces of Earth crust that are constantly shifting because of that movement of the magma beneath them.
That's right.
It's like a slow-motion dance, but with some pretty dramatic consequences.
Precisely. And it's important to remember that this movement is happening all the time.
Wow.
Even though we may not always feel it, it's this constant reminder that our planet is a dynamic system, always changing and evolving.
It's mind-blowing. So this brings us to the idea of endogenic and exogenic forces. Could you explain what those are and why they're so important?
Absolutely. Endogenic forces come from within the Earth. They're driven by the heat from the core and the pressure from the mantle. These are the forces behind earthquakes, volcanoes, and the movement of those lithospheric plates like we just discussed. Exogenic forces, on the other hand, act on the surface of the Earth.
Okay.
These include things like weathering, erosion, and deposition caused by wind, water, and ice. They're responsible for shaping those landscapes that we see, carving out valleys, forming mountains, and creating coastlines.
So basically, we've got these internal forces building things up.
Yes.
And these external forces breaking things down. It's a constant push and pull, a battle between creation and destruction that's been going on for billions of years.
That's a great way to put it. And it's this interplay between these forces that creates this incredible diversity of landscapes we see on Earth.
Now, I've got to ask about the really dramatic stuff.
Okay.
The earthquakes and volcanoes. I mean, those are the events that really capture our attention and remind us of the power of nature.
They do, and for good reason. They're these spectacular displays of the energy that's stored within the Earth. So let's start with volcanoes.
Okay.
Imagine a vent, an opening in the Earth's crust, a direct connection to that molten rock beneath the surface. This molten rock, the magma, is under immense pressure, and when it finds a way to escape, it erupts. It spews lava, ash, and gases into the air.
Wow.
That's what a volcano is. It's a release valve for the Earth's internal pressure.
So a volcano is basically like a giant pressure cooker, and when it blows its top, it can reshape entire landscapes.
Yeah.
It's fascinating and terrifying at the same time.
It is, and the impact of a volcanic eruption can be felt far beyond that immediate area. Volcanic ash can travel thousands of miles. It can affect air quality, even climate patterns.
Now let's talk about earthquakes. Have you ever felt the ground shake beneath your feet?
Oh, yeah.
It's a pretty unnerving experience.
It can be. Earthquakes occur when the Earth's crust suddenly releases built-up stress along what we call fault lines. These are fractures in the Earth's crust. This release of energy causes seismic waves to radiate outwards, shaking the ground.
So these fault lines are like weak spots in the Earth's crust,
Yeah.
where the pressure finally gives way,
Right.
causing the ground to tremble. It's a bit like snapping a twig, only on a much grander scale.
That's a good analogy. And just like the size of the twig determines how loud that snap's going to be, the magnitude of an earthquake, which is measured on something called the Richter scale, determines the intensity of the shaking. The higher the number on the Richter scale, the more powerful the earthquake.
And I'm guessing the location of the earthquake also plays a role in how much damage it causes.
You're absolutely right. The point within the Earth where the earthquake originates is called the focus, and the point on the Earth's surface directly above the focus, we call that the epicenter. The closer you are to the epicenter, the stronger the shaking is going to be.
So we've got the focus, the epicenter of the Richter scale.
Yeah.
It's a lot to take in. But it's crucial to understand these concepts if we want to grasp the impact of earthquakes on our planet and on our lives.
I completely agree. And maybe we can just pause here for a moment, see if you have any questions about what we've covered so far, about the Earth's interior, endogenic, and exogenic forces, or the basics of volcanoes and earthquakes.
So if you have any questions about what we've talked about so far, please send us your questions. We'd love to answer them.
We'd love to hear from you. We'd love to hear from you.
I'm curious about the practical implications of understanding these forces. I mean, it's one thing to, learn about the science behind earthquakes and volcanoes, but how can we use this knowledge to actually help us, mitigate natural disasters?
That's a crucial question. By understanding how these forces work, we can better predict and prepare for these events. Earthquakes, volcanic eruptions, floods, landslides. For example, knowing where faults lie and how they move can help us design buildings that are more earthquake resistant. Similarly, mapping floodplains and understanding river dynamics can inform urban planning and help reduce that risk of flood damage.
So it's not just about reacting to disasters, but also about proactively reducing our vulnerability. It's about using science to create safer communities.
Exactly. And it's not just about mitigating risks either. Understanding these geological processes can also help us manage resources more sustainably. For example, knowing how erosion and deposition work, that's crucial for soil conservation and agriculture.
That makes perfect sense. We need to learn to work with nature, not against it. Speaking of which, I'd love to delve deeper into those, slower, more gradual forces that shape the Earth's surface.
Okay.
The ones you mentioned earlier, weathering, erosion, and deposition.
Absolutely.
Yeah.
These processes might not be as dramatic as earthquakes or volcanoes, but they are constantly at work shaping and reshaping our planet over millions of years.
Yeah.
Let's start with weathering. This is the breakdown of rocks, soil, and minerals through contact with the Earth's atmosphere, water, and even biological organisms. It's like nature's way of slowly dismantling the Earth's surface.
So weathering is basically the Earth's surface getting a makeover courtesy of, wind, rain, ice, and even those tiny little lichens clinging to rocks. I never thought about it that way.
It's amazing how even the smallest organisms can play a role in shaping landscapes. And once that weathering has broken down those earth materials, erosion steps in.
Okay.
Erosion is that process of transporting those wetted materials from one location to another by agents like wind, water, or ice.
Okay, so weathering is the breakdown.
Yeah.
And erosion is the transportation. I'm starting to see the connection here.
Exactly. And then comes deposition, which is that final step in the process. Deposition occurs when that transported material is laid down in a new location. Think of it as nature rearranging the furniture, constantly moving things around, creating new landscapes.
It's like a giant slow-motion construction project, only without any blueprints. So can you give us some specific examples of how weathering, erosion, and deposition work together to create, those landscapes that we see?
Absolutely. Let's start with rivers.
Okay.
Rivers are powerful agents of erosion. As they flow over the land, they carve out valleys, canyons, and gorges. The force of the water can break down rock and carry away sediment, transporting it downstream.
Right.
That's erosion in action.
And I'm guessing deposition comes into play when the river slows down and loses some of its energy.
Exactly. When a river reaches a flatter area or enters a larger body of water, like a lake or an ocean, it slows down and its ability to carry sediment decreases. This causes the sediment to be deposited, forming landforms like floodplains, deltas, and alluvial fans.
So those fertile river valleys we see, those deltas teeming with life, they're all products of this intricate dance between erosion and deposition.
Precisely. And it's not just rivers either. Wind also plays a significant role in shaping landscapes, especially in those arid regions.
Okay.
Wind can pick up and transport fine particles of sand and dust, creating sand dunes and dust storms.
Right.
And over time, wind erosion can sculpt rocks into fascinating shapes, like those iconic mushroom rocks you find in deserts.
I've always been fascinated by those mushroom rocks. They're a testament to the power of wind to shape even the hardest materials.
They are. And speaking of powerful forces, let's not forget about glaciers.
Yeah.
Glaciers are like rivers of ice, slow-moving rivers of ice that carve out those U-shaped valleys, and they create glacial lakes and deposit vast amounts of sediment called moraines. Their impact on landscapes is really awe-inspiring.
It is incredible to think about, these massive rivers of ice slowly grinding their way across the land, shaping mountains and valleys. And speaking of ice, what about the ocean? Waves are forced to be reckoned with.
Absolutely. Ocean waves, they're constantly eroding coastlines, creating sea cliffs, sea arches, and sea stacks. They also deposit sand along the shores, forming beaches.
Right.
And they can even transport sediment to build those barrier islands.
So from the tiniest lichens breaking down rocks to the mighty force of glaciers and ocean waves, these processes are constantly interacting to create the dynamic landscapes that we see all around us.
I couldn't have put it better myself. Do you have any questions about weathering, erosion, or deposition before we move on? Anything you want to dig into?
Well, this has been a fascinating journey so far. We've traveled from the Earth's fiery core to those, windswept deserts and crashing waves.
Right.
What's really striking me is how interconnected all these forces are.
It is.
It's like a giant complex web.
Yeah.
With each process influencing the others.
You've hit the nail on the head. It's not just a series of isolated events, but a constant interplay of forces shaping and reshaping our planet. For example, volcanic eruptions, driven by those endogenic forces we talked about, can release ash and gases into the atmosphere, which can influence weather patterns and even affect those erosion rates, those exogenic processes we discussed.
It's like a giant feedback loop with, each action triggering a reaction.
Yeah.
It makes you realize just how dynamic and interconnected our planet really is.
Absolutely. And understanding these connections is key for appreciating the complexity of our world.
So as we wrap up our deep dive, I'm left with this lingering question.
Okay.
Considering how all these forces interact and the constant changes they bring about, what might the Earth's surface look like millions of years from now?
Well, that's the million-dollar question, isn't it? I mean, those continents are going to continue to drift. Mountains will rise and erode. Coastlines will shift.
All right.
As the forces we've discussed continue to do their work.
Yeah.
It's a good reminder that our planet's constantly evolving, and those landscapes we see today are just snapshots in a much larger story.
It's both humbling and awe-inspiring, to think about these vast scales of time and these powerful forces at play. Thanks for being our guide on this incredible journey.
It's been my pleasure. And to all our listeners, remember that the exploration doesn't end here. Keep asking questions, keep learning, and keep marveling at the wonders of our dynamic planet.
That's great advice. Thanks for joining us on this deep dive into the forces that shape our world. Until next time, keep exploring.